guys. So today we want to solve the 34. So 34 say that f is a differentiable function for which limit x is approach to infinity and f prime approach to infinity are both exist are finite, and which one must be true. Okay, and this problem is a little bit difficult. It's not difficult to guess the answer, but it's somehow difficult to argue exactly why this is true. Okay, so we first come up with some examples and try to use this example to cancel some false statement. So what I think about is this function. Basically, the limit exists is 1 and f prime also exists, and f prime's limit also exists is 0. Okay, so the first one may be correct, the second one is correct, and the C is not correct because 0 is not equal to 1, and f is not a constant function, and f prime is definitely not a constant function. Okay, so we have these two. Okay, so which one is correct? So one is f prime is 0, and the one is f double prime 0. Which one is correct? So basically, so I would say that the first one is correct. To argue that basically is, you use the mean value theorem that the f of x minus f of a exists for some c x minus a. So basically, suppose you fix an a, and then first you choose large a. You choose large a and then choose very large x. So this is 0, and then this a is very large. So when a is very large, this f prime of c will approximate to its limit. Suppose x goes to infinity, f prime's limit is called m. Okay, suppose it's m. So that means that f of x is equal to f of a plus m plus some constant plus some small arrow term x minus a. And then when you let x approach to very large, then this term will really close to m. But this will let the f of x blows up if m is non-zero. Right? If m is non-zero, that this term can be arbitrarily large. So the only thing to let limit f of x exist is the only way is m need to be 0. Suppose m is non-zero, then limit f of x must be blows up. So from this proof, we can see that m is 0. So that means limit x to infinity, f prime 0. Okay, but so a is correct. So the answer is a. Okay, so how about b? So remember what we have proved. So we prove limit x to infinity, f exists, and limit to x, f prime exists. Then this will implies limit f prime x to infinity exists. So suppose we want to come up with some counter example. For b. So what I mean for counter example for b is that we want to find a function. So there is this function f such that limit f exists, limit f prime exists, but limit f double prime does not exist. So we need to find a function which satisfies this property. And it took me a while to make try and error, and I think I find a function. So basically, what we want is when x goes to infinity, the double prime oscillate a lot. So when I see oscillate, what I think is the trigonometric function. So one I come out is, suppose f of x is x to the sine x alpha. Actually, I don't know what alpha is. So if I make different choice of alpha, then f prime and f double prime can have different behavior. So f prime is okay. So f prime is minus x negative 2 x alpha plus alpha cosine x alpha minus 1. So basically, you see that this is sine x alpha square plus alpha cosine x alpha minus 2. So this tells you that when x approaches to infinity, then this term must be 0. And when x goes to infinity, this term must be 0. So you can think that in order for f prime exist as x to approach 0, you need to let this 1 to be larger than 0. We need alpha minus 2 is larger than sorry. So this is 2 minus alpha. Sorry, because I flip. So we need 2 minus 1 alpha is larger than 0. So the condition for f prime is alpha less than 2. And the computation is complicated, but we know that f prime is equals to alpha cosine x alpha and x 2 minus alpha. So we can calculate the double prime. So double prime is, I only catch this term because I already know this term. Well, the derivative for this term will still be 0. Basically, I can calculate this term, and I can say that this is alpha minus 2. So basically, I can calculate double integral, not double the derivative. So this is alpha minus sine x to alpha plus okay. So you see there's a term here. So basically this term is x to alpha x to alpha minus 3 plus alpha minus 2 x alpha minus 3 cosine x alpha. So since we know that alpha is less than 2, so this alpha minus 3 is negative. So this term will go to 0 and x approach to infinity. But this term, so if 2 alpha minus 3 is larger than 0, that means alpha is larger than or less than 0.5, then this term will oscillate since the x power is positive. So that means any alpha from greater or equal than 1.5 or less than 2 will be a counterexample. So limit x goes to f will become 0, and then this f prime exists. But limit infinity x double prime cannot exist. So how we construct a counterexample by this way, and basically we construct basically infinite functions satisfy these properties, and you can use Mathematica to show these results is correct. So this problem is somewhat difficult to come up with examples, but you can use the mean value theorem to say the answer is A. So that's it.